Howdy, April Pre-Cal. It's Miss Cash. This is the second half of my 2.5 notes for this year. Yeah, here we go. So this is the part where I'm going to use my calculator more. You know what? I'm going to go back to, well, I deleted nothing just then. I'm going to go back to my main screen. This is how I always make my students clear the calculator. That's what I want to see. Kind of puts us back in the default menus. Okay, so I did some Googling yesterday. The cheapest Tesla on the market in 2024 cost $38,990. Huh, who knew? Okay, and then I also Googled and it said that new cars on average lose 20% of their value at the end of the first year. It gets a little more complicated than that, but for this problem, we're just going to simplify things. I think it loses more the first year than subsequent years, but you know what? We're just going to, so I said, assume that trend continues. Okay. And then find the value of the Tesla after 5 years, and when will the Tesla be worth $20,000? So we're going to use the function f of x, or we could call it other things with letters if we wanted to, but I just knocked my eye. My oh so fancy technology, my iPad. Okay, this would be a times b to the x. And so a is your initial amount. And so that's $38,900. The b value is your growth or decay factor. Well, this one, cars lose, that means it's a decay factor. So we would have 100% of the value, but we're subtracting away, we're losing 20% of the value, which gives us 80%. Well, in order to use 80% in my problem, I have to turn that to a decimal, so 0.8 to the x. Okay, so now I had I cleared my memory. Where's my graph? Partly because I wanted to talk about windows and stuff like that. 38990 times 0.8 to the x. On this one, I know that when I draw it, I'm not going to see too much because my initial value was really high. So I probably should have gone straight to window. And my x values, I don't know how big they're going to need to be, but we'll say 20 years after we have this car. And then we know 50,000 is above where the graph is going to be. But okay, now we've changed our window to something that probably has everything we need. What did they say? Find the value after 5 years. So G solve, come over, ycal. One way to do it is like this. So f of 5 is approximately, this is not the only way to do it. You can go to the table, you can plug it into on the regular screen, 776.24. I would write that in terms of how we actually speak, so like dollars. G solve, we can come over and do the xcal, and we want to know when is it $20,000, I think that's what it was. Yeah. Okay, 2.99, so 2.9917 years into owning the car is about, so maybe you could say 3 years in, or it's going to show up in multiple choice if it shows up, so just figure out what makes sense from that problem. Okay, once again, that's not the only way to do it. I can always exit out and say, okay, we want to know when this equals 20,000. I can draw and then do G solve and find that intersection. Okay. The next one, the number of bacteria in a sample triples every day and can be modeled with the equation F as a function of D for days is equal to 3 to the D. Okay, so this would be assuming that at day 0 we had 1 bacteria, and then at day 1 we have 3 bacteria, and at day, does that make sense? Find an equivalent form that helps us see what's happening over the course of a week. This showed up directly in the pre-cal stuff, and I was like, oh, okay. Basically, if we want to be able to think in terms of a week. Well, after a week, we've had 7 chances for things to triple. Okay, and so this is 3 to the 7th. It will be how much it has increased over the course of 7 days over 1 week. But each day is a 7th of the week. Did I say that correctly? Yes. So the number of days divided by 7 tells you how many weeks we have. I think this would show up in multiple choice, and but notice this is equivalent to what we had here, because the power to a power you multiply, and this would be this 3 to the 7 times D over 7, which is just 3 to the D. Okay, whatever. Then they talk about using the variable e. It's not a variable, the constant e. I lied to you. And so I wrote a problem where we put in e. And so this you may recognize as the formula for compounding continuously. I don't remember. So AP Pre-Cal will give you no formulas. but I don't remember them needing you to know the different compounded formulas, the half-life formulas. I mean, it's not a bad idea to know them, but I don't remember making any like extra effort to make my kids memorize it last year, and I think they were fine. So if you know differently than me, comment down below. But otherwise, they'll like write some weird formula and then have you manipulate it and use it and interpret and all that kind of stuff. Okay, so here, this is that formula. I find an account that offers 5% interest, which would be amazing these days. Okay, how long will it take for my money to double? So the amount that I have ends up as twice my principal. So you could think of it that way. So 2p would equal p times e to the rate is 0.05, and we're trying to find time. Notice I can divide p from both sides. Or what I could have thought about is that I could let p equal 1, then that means that a would equal 2. Or 100 and then 200, and then you divide it away, whatever. Okay, so I have a calculator, and I would come here and delete this mess and delete this mess. And I'm going to say this is e, nope, that's natural log, second e to the 0.05 times x. And I want to know when it equals 2. So here's one I just typed, I was ready to type them both in. Oh yeah, my window's terrible. Okay, to 10, maybe a height of 10, because we don't need to. Okay, there's my intersection. I can GSolve, find the intersection. So 13.8629. 13.8629 years later, so maybe 14 years. Okay. And then the last problem here, they want us to do a regression. So we have done some regressions already, but now, okay, so to do a regression, we go into statistics, and I'm going to type in, not 46, 4, 6, 8, 10, 12, type this in. Hopefully I'm typing it in correctly. 2, 3, 4, 1, 2, 4. If I make a mistake, comment down below. 2, 6, 6, 0, but be kind. We have enough negative in this world. We can be kind to each other. I've decided the people who I don't know don't get to live in my head rent-free. So be kind or I ignore you. Okay, true story. Life lessons from Ms. Kosh. Okay, so I'm going to graph that. And then they're telling me to do the exponential regression. And so I have the option of using a base of e, but they told me in the problem not to. They told me to do f of x equals a times b to the x. So there it is. I'm going to copy, hit enter. Before I hit draw, I'm going to write it down. Y equals 2195. Let's hang on to 4 decimal places. 6892 times 1.0325 to the x. Okay. This tells us that this is our growth factor because it's bigger than 1. It tells us that we have a 3.25% increase. Okay, because we're making 103% of what we had the previous years. Okay, so how much money would I expect in the year? So I can draw this. Great. Can we do like the GSolve stuff? I don't know. Okay, so now let's come back to our graphing world. There we are. Let's turn that graph on. Let's delete this. We don't need that anymore. But when we draw this, it's helpful to notice that the window is only going to x values of a little more than or a little less than 14. But they're asking me to make a prediction for the year 2016. So and my calculator can't do it if it's not in the window. So let's make this a little bit bigger. And then I know that I need to know $4,500 here. So let's make our y values. We can change this later, and if you find, actually let's not change that, and I'll show you what happens if you don't change it at this point. So draw, I changed one of them. So then I can do GSolve. I want to know at xcal, nope. I want to know, draw, GSolve. I want to know ycal when at the 16 years after 2020. And so that was inside the x value is inside my window, the y value is not, but that's okay. And so this is 3662.6, that was a 2, dollars. Okay, is this an interpolation or extrapolation? This is an extrapolation because it's outside our data set. And so who knows, we could predict that this will be the amount of money, but we might have a hurricane that knocks out the bank and the whole, I don't know, whatever, I'm making stuff up. We could have a huge recession and you lose all, and all money is gone. I don't know. We could have an asteroid hit. So an extrapolation we are less sure about because there are crazy events that could happen that could change the trajectory of our graph, of our world. So that's an extrapolation. The next one, the year 2007, shows up, not there, shows up in here, and that's within the data set. So we are more confident that that would be accurate from our, I just wrote on my finger, okay. And so we can do G solve y cal when x equals 7, and that was 2746.86, that's 6. What did I said all the wrong things. Not 2746.59 is how we would round that in terms of money. That was an interpolation, which was within the data set, and we have more confidence in that value because the world didn't implode before the next data point, if that makes sense. When would you expect the account to be worth that? Okay, so I can do G solve, do an xcal 4500. Not found because it's not, we need it in our window, so I can go exit and then go to window, shift window. I might need bigger values here. I don't know. Let's go to 30 just in case. And then let's go 5,000 so that we can kind of see where we need to be. G solve xcal 4500. And there it is. Okay. I wonder, did I need to go higher? I definitely needed my x values to be bigger. So about 22.0. So in the year, this is 2022. No, not quite. It's really kind of 2023, depending on how you answer the question. It would show up in multiple choice. All right. Like, subscribe, comment, and go practice. So good luck to you.